All right, today I'm going to make sure that you know how to interpret and you correctly know how to read a triple point diagram. And so what we have up here right now is a triple point diagram for water. And down at the bottom, our independent variables are temperature in degrees Celsius, and our dependent variable on the side is pressure, and we're using kilopascals for our pressure unit. Now, something that we need to make sure that we notice and note on this is right down here at the bottom, it says the scale of this graph is distorted to emphasize some features. So if you look right here, down here at the bottom at this and this, 0.016 is definitely really close to 0, but we've kind of moved it a little bit just to make the graph, some of the features easier to kind of read and see. So keep that in mind when we're doing this graph. But we're going to start out by labeling some of the parts. And we're going to start with normal boiling point and normal melting point. Now this is something we've talked about. We've been talking about the boiling point of water is 100 degrees. And even yesterday we talked about, is that always true? And the answer to that is no, it's not always true. There's only one place that water boils at 100 degrees, and that's at sea level, which is at 1 atmosphere, 760 millimeters of mercury, or 101.3 kilopascals. Now we're using kilopascals today, so we know normal boiling point for water happens at 101.3 kilopascals. And normal melting point of water would also happen at 101.3 kilopascals. So on this graph, we're looking for really 101.3 kilopascals, and we find it right there. Now we know that water freezes at 0 degrees Celsius at 101.3, so if we follow our graph down and find 0, I think this point right here would be our normal melting point. So we're going to label that B. All right, normal boiling point, again, is at 101.3 kilopascals, and we know that should be 100 degrees Celsius. So we find 100 degrees, we find our 101.3 kilopascals, and that's our normal boiling point. So normal boiling point should be 101.3 kPa and 100 degrees Celsius. Normal melting point should be 101.3 kPa and 0 degrees Celsius. All right, at this point, we have 3 distinct areas of the graph. We have this area right here, we have all this area right here, and then we have this area right here. All right? Well, if this area to the very far left of that B is where freezing is, it makes sense to me that this part of the graph is where we have a solid. All right? If on the other side of A, we have boiling, and we know boiling goes down, boiling point goes down as pressure goes down, then that means that everything on the right-hand side of A should be a vapor, which is C, which means everything in the middle is a liquid, E. So this area right here is a solid, this is a liquid, and anything over here is a vapor. All right, that takes us to triple point. All right, we know by definition that triple point is the area or the conditions, both temperature and pressure, where a substance can exist as a solid, liquid, and a gas all at the same time. Well, in this graph, there's only one place where that area where it's a solid, a liquid, and a gas all come together, same place, same time. And it's this point right here. At that point, you have a solid, liquid, and a gas all occurring at the same time. So that is my triple point, F. All right, G through K ask us to use an arrow. And what we're going to do is use an arrow to show where those phase changes are occurring. All right, so condensation. We start with G, condensation. Condensation means we start with a gas and we go to a liquid. So anywhere along this line by C, we can do condensation. So I'm going to put it just right here. I'm going to put my G and I'm going to show my arrow going across because I'm going from a gas or a vapor to a liquid. All right, melting. Melting, we have to start out as a solid and we're going to go to a liquid. So anywhere along that line where the B's at, would be melting. I'm just going to put it right here. And I'll put my arrow going across because I'm going from a solid to a liquid. All right, freezing. Exactly the opposite of melting. In freezing, we're going to go from a liquid to a solid, which again is going to happen on this line where the B's at. So I'm just going to stick it down here. And this time my arrow is going to go across this way because I'm going from a liquid to a solid. All right, boiling. Boiling, we have to go from a liquid to a gas. So anywhere along this line here, I can put this. I'm going to put it right there. I'll put my J, and my arrow is going to go across, showing that I'm going from a liquid to a gas or a vapor. And then the last one, sublimation. Sublimation, if you remember the definition of that, that is when we go from a solid directly to a vapor or gas. In other words, we're skipping the liquid phase. No liquid's happening here. There's only one place that can happen, and that's where my solid and my gas kind of come together, and that's going to be right down this bottom kind of left-hand corner. So I'm going to put K down here, and my arrow is going to go across this way because I'm going from a solid directly to a gas. All right. The next question up here says, what is a triple point of water? And again, triple point has to have two conditions. It has to have a pressure and it has to have a temperature. And so I know triple point is this arrow or this point where it says F, and that temperature or pressure would be about 0.61 kPa, and it would be about 0.016 degrees Celsius. All right, last question. Ask, is ice more or less dense than water? And it also asks which way is the line sloped. So let's think about this for a second. Is ice more or less dense than water? And if you've ever put ice in a glass of water before, you know that it floats, right? So we know that ice is definitely less dense. All right, if we look at our line of equilibrium, which is right here, between a solid and a liquid, that's our line, right? We see it slopes kind of toward the solid side, right? Well, if it sloped the other direction, let's say for a minute it sloped this way instead, we would know that ice is actually more dense. But it doesn't slope that way, so we know ice is less dense. So that is a triple point diagram. Hopefully this video helps, especially if you weren't here the day that I taught this. Hopefully this helps you a lot.